Well, hello guys and welcome back to Mr. G Physics. Here Mr. G, and this time we're going to be doing another question for the grade 12 and grade 11 related to electrostatics, which is a very important topic. That you can have up to 2 questions in grade 12 in the examinations and 1 in grade 11. But before we move on, just subscribe for the channel and like the video so you can get the notification and more videos I make on regular basis. Well, this is question 7, or it was question 7 done in the Western Cape, in 2023 in the September examination for the grade 12, but is extremely applicable. It's the same for the grade 11 with no difference in here. This question states the following. Sphere B carrying a charge of positive 2,3 microcoulomb is suspended from the ceiling by an elastic string. Point B, that's how the cast passing by. Point P is 5 centimeters to the left of sphere B. So we have the picture with the sphere B, a specific microcoulomb of charge. Now, note you cannot work in microcoulomb, so you have to convert. How do you convert? You need to know that 1 microcoulomb is equivalent to 10 to the minus 6 coulombs. You need to convert. That is an important conversion, and most of the time you're going to work with microcoulombs, so you will have to convert. Also, you cannot work in centimeters, and you have to convert from centimeters to meters. You have to divide by 100. So this one is 5 divided by 100. I just write it in case somebody don't remember later on. So this one is 0,05 meters. We're working in meters. We're working in coulombs, no microcoulombs. Define the terms electric field strength at a point. And I want to show you something. When you go to the exam, in the exam, there are formulas at the back. There is a formula for electric field at a point, which is E equal to F divided by charge. Guys, this formula is the definition of electric field at a point. How we read that one? This one is force per unit positive charge at the point. That is electric field at a point. That is the definition and is in the formula. Something important that we have to take from here, electric field is a vector quantity. It's a vector, and therefore it has magnitude and direction. Those are important points related to electric field at a point. The symbol is capital E, is force divided by charge. We read force per unit positive charge. The part positive is important, otherwise you won't get the mark. There is 2 marks for the definition, guys, which is given to you in the formula. So you shouldn't make that mistake. Question 7.2, calculate the electric field strength at point P due to sphere B. Now, there is another formula. We can use this one if we know the force, but we don't know the force. So there is another formula that we can actually use for this situation because the electric field is a non-uniform electric field. Electric field is equal to K multiplied by the charge divided by the distance squared. That is the formula we are going to use for this specific question to calculate the electric field. So we have everything. K is a constant, guys, that you get in the table of constants. So we can substitute E is equal to 9 times 10 to the 9. I think I can move all this one a little bit down. I'm trying to save space. And with the space saving, I'm taking compressing too much. So times 10 to the 9 times the charge we convert, which is 2,3 times 10 to the minus 6. Remember, you have to convert. The distance is 5 centimeters. When you convert it, it's 0,05 squared, and the rest is calculation. So electric field at point P due to charge B is going to be equal to, when you do the calculation, and then the answer is going to be 8,28. Space here, the space here, 8,28 times 10 to the 6 Newton per coulomb. That is the unit. Now, we need a direction. Electric field at the point is a vector quantity as we just say, so we need a direction there, which is missing. Now, how do we get the direction of an electric field? Remember, we take in that point P is not a charge, but we take it to give a direction, like if we place there a positive charge. So here, the direction is going to be pointing to the left, but in this case we're using yes, left. So it is going to be pointing to the left, as you can see there. Remember, that point is not a charge. I'm repeating myself, but it's like if you place a positive charge at the point. So here the direction is left. If there is not left, you won't get the mark. There are 3 marks, 1 for the formula, 1 for the substitution, 1 for the answer. It's quite simple. So far, we can get 5 marks of this question. Let me just have a sip of coffee. Now, the next question says, 2 other spheres A and B are placed on opposite sides of B, each on isolated stands as shown in the diagram below, and they show you here the diagram of what is going to happen now. I'm lost here. Isolated stand as shown in the diagram below. Sphere A carries a charge of minus 0.7 microcoulomb. Remember, we have to convert. We can actually convert already here. So this one is 0.7 times 10 to the minus 6 coulomb. And then sphere C, we don't know how much is it the sphere. This one is still 2.3. Let me just 2.3 times 10 to the minus 6 coulombs. That is what we have. The distance here is 0.15 meters. The distance here is 0.1 meters. So we have all the information given. They say first B moves towards sphere A and comes to red. So it means it's not moving here. All right, it's not moving. Speed is equal to 0 at that specific point. So that the suspended at an angle of 50 degrees from the vertical and remains in equilibrium. So that angle here is important because of the next question we're going to do just now. The tension in the string is 0.09 Newton. Another important data. Tension in the string is equal to 0.09 Newton. We're going to just use in the next upcoming question here. The question said, draw a label free body diagram of all the forces acting on sphere B. So what forces are acting on sphere B? Now, this is not also a big deal, but what forces are acting there? First of all, there is a force from A, which is negative, acting on B. B is positive. Negative attract positive. So A is pulling B to the left. So if we represent a force, and I'm going to write it here, let me maybe use this other color here. Then we have this one is F, A, B. All right, it's pulling B to the left. C is also pulling that to the right because we don't know the charge, but we know it is negative. So it is going to be pulling to the right. This one is F, C on B. We have the tension. There is the rope that is pulling in that direction. This is T. And then we also have weight, which is pointing down, or gravitational force. Now, this I draw here is not the free body diagram. A free body diagram, you have to represent it with a dot and all the forces coming from that specific dot. Now, if you do it differently, you will lose marks. You cannot draw a force diagram no more. It's not been accepted any longer. You cannot include the components. It's not accepted any longer. So the only way is to have a dot and the forces coming off the dot. So you have here the tension, which is pointing in that direction, is not have to be at scale. So it doesn't need to be extremely accurate. This is T. We have FA. This one here is F, let me fix that one there. This one is F, A on B. We have here to the right F, C on B. And finally, we have weight or gravitational force. Normal? There is no normal. For normal to be present, there must be a surface. that sphere B is hanging, is not a surface. Now, this is 4 marks. You must also look at the number of marks that you have in the question, because when you draw in free body diagram, which you are going to have a couple of them in the exams, you will get 1 mark per force. So if there is 4 marks, it means there are 4 forces. So it's 1, 2, 3, and 4 forces. That is the free body diagram for this specific question, which is quite simple. Next question, calculate the charge on sphere C. Now, this is perhaps the tricky part in the question, because it is a relation between electrostatic and a little bit of Newton's law of motion. Now, for this question, I always recommend the learners to draw the free body diagram, but completely full, with all the components, perhaps the axis, etc. Remember, it cannot be in this one because you will lose the mark. So now we have to draw a free body diagram, which I'm going to draw right here. This one is for question 7.4. You can do it in scrap paper, you can do it in the question, wherever you have a space. So I'm going to include the axis. Not accurate, not ruler needed. I don't have time for ruler, don't waste time, but I will include the axis. So this one is X, this one is Y. Now tension is in between. This is why I include the axis. Tension is in between. It means it must be projected to the X to have what we called T in X. This one is T in X, and it must be projected to the Y, and this one is what we call T in Y. Now, the angle, people attempt to remember, or learners attempt to now memorize and say in X is always cos, in Y is always sine. It is not like that, guys. You have to look at the angle. The angle here is not known. We know the angle on top. This angle is 50 degrees. That is the angle you have there in the exam. Look here at the picture. That is the angle you have in the question. So if you look at that one, you can see that T in X is what we call opposite side. In other words, we're going to use sine theta. If you look here, the F or the T in Y is the adjacent side, and is when we are going to use cosine of theta. Now this one is just for T. Apart from this one, remember you still have the weight, which we are not going to use in this specific question, but it is there. So let's do it. You have still the force that A exerts on B, which is in this direction, A, B, and you have still, apart from this one, you still have here the other force, which is, I'm going to write it here, T. It's not, it's a force from C on B. So those are the forces. Now we're going to work with the X direction, in the X axis. So this is what we're going to deal with in here. All right, this is Newton's law. I'm going to use this space here to write that part. Now, what we are going to start saying? We're going to start using Newton's first law. Now, why am I using Newton's first law, guys? Because the object is not moving. It is at rest. According to Newton's first law, you use Newton's first law, or according to Newton, when the object is at rest. So we have to say that F net is equal to 0. Guys, we are working in X axis. And the direction is entirely up to you. We have right or left. Let's write right as positive. Right is positive. Okay, it means all the forces that are pointing to the right are positive, and all the forces that are pointing to the left are negative. You can do the vector addition first and then work with the projection. It's entirely up to you. So I'm going to already project this one. We have F. A on B is negative because it's pointing to the left, plus force C on B. Let me not write C on B, let me write CB, plus tension in the X direction, and this one is equal to 0. Now, why am I doing all this, Mr. Gomez, if we were not asked to do this one? Well, we are looking for the charge C. The chart C, we can use it in this specific formula, which is Coulomb's law. CB is equal to K, charge B, which we know, charge C, which is what we are looking for, divided by the distance squared. That is why we need, in other words, to calculate, let me just use a pen, we needed to calculate that force. We need that force. So that is why we're working with that specific Newton's law at that point. So saying that, to calculate the force C on B, if you rearrange from here, you get that the force CB is equal to F AB minus T in X, which T in X, remember, is going to be sign because it's opposite side. And we are almost done. All we have to do is now to calculate the force from A on B and the T in X. You can work all in one equation or you can calculate it separate. It's entirely up to you guys. I'm not going to impose this one. But the force A on B, let's go to a new page because the space is not going to be enough. New page, you can see work. There we go. So here we are with a new page, and then, oh my goodness, is let me go here. I'm going to write it here and take it down because the space is a little bit too small. So I'm going to write it here because of data. So the force A on B is equal to K, charge A, charge B, divided by distance squared. If we substitute here, AB is equal to 9 times 10 to the 9, all the information is given. So it's not a big problem of substituting time. Charge A, we know it, let's move up, is 0.7 times 10 to the minus 6, and I'm going to speak about something there. 0.7 times 10 to the minus 6, maybe I can move, I keep struggling with the space here, guys, and I don't really want to struggle. The minus 6 is gone. Let me just fix it quickly. Minus 6, sorry, minus 6 times QB, which is known by us. We even use it, 2.3 times 10 to the minus 6, everything divided by 0.1 meters, 0.1 square. Now, important, and this is important, you cannot substitute the minus in this formula. This formula is positive, is everything. So now we are done. All we have to do is to calculate. I am going to take it to the new page so I can use my calculator. Let me cut, and then let's go to a new page, guys. Moving to new page, here we are. I'm sorry for taking so long and make you wait. Here is the question, paste, there we go. And now I'm going to use my calculator in the meantime. You can do the calculation on the other side of the screen to see if you get the same answer as I do. So now here, times 0.7 times 10 to the minus 6, times 2.3 times 10 to the minus 6, and then divided by 0.1 square. Guys, I get the answer here is 1.45 times 10 to the 0 Newton. Okay, and this one is going to be to the left. That is going to be to the left. So we have already the force A on B, which is 1.45 times 10 to the 0. You can write it like this. You don't have to write it in scientific notation. If you don't want, let's go to the question and place it right there to keep the data together. Okay, if you see this question paper is almost done. We're almost done with this question paper, which is important for the grade 12. Here we are. I'm going to write it here. And here is the force. This one is F A B. All right. Now T in X, guys. How do we calculate T in X? We say it's sine because it's opposite side. So T in X is going to be, and then I'm going to write it right here. T in X is equal to T sine 50. T, we did write the data there, 0.09. So it's 0.09 sine 50. There we go. So t in x is going to be, let me write it, 0,09 sine 50. I'll get 6, I have using my calculator here and moving in this direction. 6,89 times 10 to the minus 2. This is 6,89 times 10 to the minus 2 Newton. There we go, also to the right. But we don't have, because we already were with the projections here. So the rest is just calculating FC in B. So if we calculate FC in B, let's copy all this one down, because we are going to finish in a minute, or this one, to just make more space. We're going to try to make more space, guys. I am showing you here. I don't want to stop the video and then restart and edit all that. It's not a need with you guys. So here we go. That is what we have. So saying this one, new page, we can calculate now the force from C on B. F CB is equal to, and then we have 1,45 times 10 to the 0 minus 6,89 times 10 to the minus 2. FCB is equal to, once more I'm going to do the calculation real fast, is 1,45 times 10 to the 0 minus 6,89 times 10 to the minus 2. The answer is 1,38 times 10 to the 0 Newton, and that is to the right. We don't need the right at the moment. We already have it here. We don't need, because all we're looking for is for the charge. So we actually don't need that direction anymore. So FCB is equal to K. So now we can substitute for a B. Let's go here. We have that formula, FCB is equal to K QC. Let's write B first. QC divided by distance squared. So if we substitute here now, we have that this one is 1,38 times 10 to the 0 is equal to 9 times 10 to the 9 times 2,3 times 10 to the minus 6. If I'm not mistaken, let me make sure with this substitute there. It is 2,3 times 10 to the minus 6 times QC we're looking for, divided by the distance. And if I'm not quite sure, but I think it was 15 centimeter. In other words, 0,15. Let me just make sure, guys. 15 centimeters, 0,15. So here we are. Is 0,15 square. So from here, you may calculate now the charge C. All right, so let's quickly do that. Charge C is equal to, now is 1,38 times 10 to the 0 times 0,15 squared divided by 9 times 10 to the 9 times 2,3 times 10 to the minus 6. The answer should be, let me recalculate, I'm using the calculator real fast here. So the answer after calculation, please calculate on your side and let me know if I make any mistake. I'm not good with the calculators, guys. 0,38 times 10 to the 0 times 0,15 square divided by 9 times 10 to the 9 times 2,3 times 10 to the minus 6. Then the answer I get here is 1,5 times 10 to the minus 6 coulomb. But let's go back to the question, because there is something I just want to make sure. I don't want to make a mistake here. If I'm not mistaken, they ask for the charge in microcoulomb. There we go. Guys, they're asking for in microcoulomb. So we have to move back now. In microcoulomb, that one will be the answer would be now in microcoulomb just 1,5. You remove the 10 to the minus 6. So the final answer for this question, which is quite weird, I don't need those colors, charge Z is equal to 1,5 microcoulombs. This is the final answer for this specific question. It is a good question. It is different from what we have done up until now, so I like this question. Now, marking wise, you will get 1 mark for, obvious, this formula will carry 1 mark. You'll get 1 mark for calculating the force A, B. Let me see the number of marks. I don't quite remember once more, and I'm really sorry to be up and down within the question. 7 marks. So that is 1 from starting from Newton's law. There's 1 mark for starting from that point. Any of those points, there's 3 marks. There's 3. And then we go to the last part. We're almost done. We just giving marks. 1, 2, 3. 4 to calculate t in x. 5 to calculate here. 6 to come to this size substitution, and 7 for the final answer. Guys, this is the end of the question. It's a really good question. I hope it helped. If it helped, all you have to do to support the channel is thumb up. Thank you for watching. I'll see you next time, Mr. G.